Hey there, and welcome to This Explainer. Today, we're literally lifting the hood on AI to demystify the magic that's powering the tools we use every single day. If you've ever found yourself wondering how exactly a simple prompt turns into a fully realized essay, or how an AI can just generate a lifelike human voice out of thin air, well, you're absolutely in the right place. Today, we aren't just looking at the shiny surface. We're digging deep down into the very foundation of artificial intelligence. Okay, let's quickly map out our architectural floors for today. We'll kick things off by deconstructing the AI stack. Then we'll explore Layer 1, AI models, Layer 2, computing infrastructure, Layer 3, cloud delivery, and Layer 4, user applications, before bringing it all together and seeing the layers in action. All right, Section 1, deconstructing the AI stack and building the foundation. Most people just think of AI as a single application, but today, we're going to fundamentally change how you look at this entire ecosystem. We really need to ask ourselves, is AI just ChatGPT, or is it actually a four-story building? When you fire up a tool like ChatGPT or use a smart route planner, it's super easy to assume that one single app is doing all the heavy lifting. But in reality, every AI application you interact with is supported by a towering four-story infrastructure. Each floor has a completely different responsibility, and they all work together to create the intelligent applications we rely on. A really great way to picture this entire stack is by using a simple kitchen analogy. Think about it like this. Layer 1, the AI model, is the chef writing the recipe. Layer 2, the infrastructure, is the kitchen itself, providing the gas stove and the electricity. Layer 3, the cloud, acts as the delivery service, routing the food. And finally, Layer 4, the application, is where you, the customer, actually get to sit down and eat the meal. You can't just have a recipe and expect dinner, right? You need the kitchen, the delivery, and the plate to eat it on. Otherwise, you're just staring at a piece of paper. Moving on to Section 2, Layer 1, AI models. This is the brains and the chef of the whole operation. Let's start right on the ground floor, where the actual intelligence of our recipe is forged. So here's the absolute crucial point. These foundational brains, they aren't magic. They are fundamentally just executing something called next token prediction. It's basically a mathematical guessing game to figure out the most likely following word. When we say an AI understands a prompt, what's actually happening under the hood is deep statistical analysis. Based on massive amounts of training data, the model looks at your text and predicts the most probable next piece of text, or token, over and over and over again. As our sources from legal AI training point out, understanding this one single concept really takes the surprise out of AI. It perfectly explains why it can sometimes sound incredibly confident, even when it's totally hallucinating or getting a fact wrong. Now, there's a huge difference between massive foundation models and highly specialized ones. On one side, we've got foundation models like GPT-4 or Claude. These are massive, general-purpose reasoning engines that can handle everything from writing code to summarizing huge documents. But on the other side, we have specialized models with a very narrow focus. A perfect example of this is a text-to-speech, or TTS system. Modern TTS systems are driven by deep neural networks trained specifically to correlate text transcripts with audio waveforms, which allows them to predict and generate highly realistic human speech. They are unequivocally AI, but they're built for a very specific, narrow task. All right, Section 3. Layer 2. Computing infrastructure. This is the kitchen powerhouse. Moving up a level, we enter the hardware layer that provides all the essential heat and electricity. 1 trillion calculations per second. Just think about that for a second. Training and running these models requires a staggering scale of computing power. We're talking about executing trillions of math problems every single second. Normal computers simply cannot handle this kind of load. When an AI is generating a complex image or reasoning through a massive document, it's churning through a mathematical workload that would literally take a standard laptop days to complete, and it's doing it in the blink of an eye. And to hit speeds like that, we rely heavily on specialized hardware like GPUs, graphics processing units, from companies like NVIDIA. They were originally designed for video games, but GPUs are uniquely capable of performing thousands of calculations simultaneously. But it's not just the chips. This layer also requires high-bandwidth networking to connect massive server clusters, enormous data storage, and incredibly intense cooling systems. In fact, those cooling systems are required just to keep this digital kitchen from literally melting down. This is the heavy physical reality of our digital AI architecture. Next up is Section 4, Layer 3, Cloud Delivery. This is the routing service. Let's see how all of this builds into a network that brings the cooked meal right to your digital door. I mean, you aren't downloading a massive AI supercomputer onto your personal laptop, right? Instead, cloud platforms host the intelligence remotely and securely route your requests back and forth in milliseconds. Companies like AWS, Google Cloud, and Microsoft Azure provide this vital layer 3. They basically take the models from layer 1, host them on the heavy infrastructure from layer 2, and make them available to billions of people over the internet. They manage secure access, handle sudden spikes in user traffic, and ensure that when you hit enter on your keyboard, your data routes exactly where it needs to go instantly.
And that brings us to Section 5, Layer 4, User Applications. Basically, the dining experience. Finally, we reach the top floor, where you actually get to sit down and enjoy the interface.
So what does a sophisticated Layer 4 application actually look like? Well, a great example is a multi-agent video generation pipeline. Our sources from Mind Studio make a really great point here. Asking just a single AI model to do everything usually results in pretty mediocre output. Instead, a multi-agent workflow assigns specific tasks to the right specialized tools. Agent 1 uses a language model to write a script. Agent 2 connects to a specialized text-to-speech API for the voiceover. Agent 3 prompts a video generation model for clips, and Agent 4 assembles the whole shebang. The user simply types in a topic, and the Layer 4 application orchestrates all this complex routing over the lower layers to deliver a fully polished marketing video. Now, there's a really important warning from our legal training sources that perfectly hits the nail on the head. Skipping straight to the application layer without understanding the foundations underneath produces the most expensive errors. Whether you're a lawyer analyzing contracts, a developer building an app, or a marketer generating content, leading only with the tool means your knowledge is going to be outdated in about 6 months. But if you understand the 4-layer base, how models predict tokens, where the data is routed, and what hardware is powering it, you can easily adapt to any new tool that comes out. Real quick aside, while these 4 layers make for an awesome mental model, the real world can kind of blur these boundaries sometimes. For instance, if a company decides to self-host an open-weight model on their own servers for privacy reasons, they're effectively merging the model, infrastructure, and delivery layers all under their own roof. Or sometimes a massive cloud provider packages all the layers into one giant platform. But hey, even when the boundaries blur, the core functions of the recipe, the kitchen, and the delivery absolutely still have to happen. Okay, Section 6, the layers in action, the journey of a prompt. Let's tie it all together and track exactly how a single request travels through our 4-story building. Imagine you ask an AI to plan a 5-day trip to Dubai. First, the Layer 4 application catches your prompt through its user interface. Second, Layer 3, the cloud, securely routes that request across the internet to a massive server farm. Third, Layer 2's powerful GPUs spark to life, executing billions of calculations to process the data. And finally, Layer 1, the trained model, utilizes its next token prediction to reason out a helpful, logical itinerary. The response is then beamed right back up the chain to your screen, all in a matter of seconds. It's like a giant, lightning-fast puzzle. With the magic finally demystified and your foundational knowledge rock solid, you can see that AI isn't just some single magic trick. It's a beautifully orchestrated ecosystem. You understand the recipe, the kitchen, and the delivery service. So the only question left for us is, armed with this deep understanding of the stack, what incredible application are you going to build on the 4th floor? Thanks so much for joining me on this explainer, and I absolutely cannot wait to see what you create.